Okay, I want to talk about variation of parameters for systems of equations. Now, this is a typical non-homogeneous system. Of course, this would consist of some number of equations, like, y1 prime equals 14y1 minus 3y2, okay? Plus something that doesn't involve y, the non-homogeneous part. And then you'd have a y2 prime equals some combination of y1 and y2 and so forth, okay? Just to put you in context. And we have seen how we can represent the system like this, okay? And this is the way we want to represent it, so we can do the variation of parameters, which turns out to be much simpler for systems than it is for an individual equation. Now remember, for an individual equation, our premise for variation of parameters was that we have a solution, okay, we have a fundamental set, okay, and we do something like a linear combination of the fundamental set, except it's not a linear combination because you multiply each member of the fundamental set by a function, okay? So it's like you have y1 u1 plus y2 u2 and so forth. And then we work through that and we find that you get equations for the derivatives of the u functions, okay? And hopefully you remember that. If not, you should review it before you totally think through this. We assume now, in this case, that we have a solution matrix for the system. A solution matrix is just the matrix psi that consists of, whose columns consist of a fundamental set of solutions, right? So you solve the system, you get your column vectors, well, you get your vector solutions, and those solutions form the columns of the psi matrix, okay? So that's the definition of the psi matrix, and we've used that previously, so we should be familiar with this. So we're going to assume that there exists a solution to the non-homogeneous equation that's of the form psi times u. That's just equivalent to like a linear combination, but with not linear because you're using functions instead of constants to form your combination of your solutions to a single equation, okay? So this is totally analogous, and you should understand the analogy between this assumption and the assumption we used, the premise we used to do variation of parameters for a second order equation or whatever. Okay? So there's our premise, right? Now if we put this function, okay, well, it follows that psi u prime should equal p of t times psi u plus g of t. So all we want to do is, well, what's psi u prime? Well, psi u prime is psi prime u plus psi u prime. So there we have the same equation, just replacing psi u prime with what the product rule tells us. Okay? Now, psi prime equals p of t psi, doesn't it? Because that's what it means for psi to be a solution to the this equation, okay? And if psi is a column of solution vectors, then it is a solution to this equation, as we saw a week or two ago, okay? And if you don't understand that, make sure you write it out and review it and understand it, okay? If you want to understand this method, okay? Now, psi u prime equals p of t psi, is there a way to use that to simplify this equation? Because if there is, you're almost done. So think about that for a minute.